What you are watching is a precision pendulum, and it is being driven by the magnet, which is being controlled by the control board using a PIC microprocessor on the C-stamp. It is controlled by a shutter blade that is on the back of the pendulum as it passes through an optical sensor. As it passes through the sensor, it determines that a swing of the pendulum has occurred, and then it decides whether or not it needs to pulse the pendulum. In a minute I can focus in farther on the two green flashing LEDs. The one in the back, when it is lit, is the pulsing of the pendulum. The one in the front just says that the pendulum has passed. So if you just watch it there for a little bit, the front yellow LED is just a power LED, and the C-stamp is wired to be self-starting. 38 pin is tied low. Here you can see the bottom of the pendulum passing over the magnet, and in back you'll see what appears to be a flat black piece of steel passing through another black plastic little optical sensor, and that's the shutter turning on and turning off the pulsations to what will be a slave clock, and then the magnet, when necessary, turns on to provide the power to overcome the friction and the drag on the pendulum. Here you can see the two green flashing LEDs. The one in the front is just the counting the pulses, or it is a seconds pendulum, so essentially it's counting the seconds. It hasn't been tuned yet to be exactly 1 second at this point. The LED again in the back, it just pulsed there. That was turning on the electric magnet. We're using a PWM to drive the magnet. There are 3 blue potentiometers in the front. One sets the duty rate for the pulse width modulation. The one in the center decides how long, or how often I should say, the pulse goes. In other words, should it be every 1 stroke or every 10 strokes? It goes up to every 12 strokes. And then the potentiometer on the far left is that just decides the amount of time that the magnet is actually on, and presently it's programmed to go up to 100 milliseconds, but you can turn that down to have less. My experiments show that the pendulum will stay very well pulsed at a 50% duty cycle and running at only 1 stroke every 10. In other words, 1 pulse out of every 10 stroke or 10 passes of the pendulum. So that's it.